Hi everyone, welcome to week 5. This week, this first section is 10.9 and it focuses on circumference and arc length. So some of this might actually be a little bit of review for you. So we already know the circumference of a circle is really just the perimeter of a circle. And the ratio of a circle's circumference to the circle's diameter is the constant pi. So that definition actually leads us to our circumference formula. If I was to multiply by d on both sides, I would get circumference equals pi times diameter, or we also know it to be circumference equals 2 pi r. So cherry pie delicious, or 2 pi r. And we're actually going to use the circumference to help us solve for arc length this week. So arc length, which is going to be represented by the letter L, is found through its proportionality to the associated central angle. So what do I mean by that? In this diagram, you can see that there are 2 radii drawn in. So r represents the radius. X is the degrees of this central angle right here. And L is our arc length. So from one radii to the next. So we're trying to figure out how long is this arc. Not how many degrees, but length. So we're talking inches, centimeters, whatever it may be. So in our formula, we're actually going to create a proportion anytime we want to solve for arc length or a missing central angle or maybe the radius. So the length of the arc over the circumference will always equal the degree of the central angle over 360. So you can always think about it as length is to length, as degree is to degree. And actually, this is the better formula that I use all the time. I don't put C. I typically actually just plug in 2 pi r. And that's because this specific proportion connects the arc length L to x degrees to r, which is the radius. So this is the one I'm going to be using more often. So that is the gist of 10.9 notes. If you know this proportion, you'll be good to go. So the rest of this is really just going to be practice. So here are your first 2 questions, your basic, can you find the length of the arc? So they're telling you have a 12 centimeter radius for this circle. I'll actually do the first one for you. So they want to know what's the length of a 30-degree arc of a circle with a 12 centimeter radius. So I need to fill in this proportion. So L is what I'm searching for. Okay. I have to plug in the circumference, so 2 pi r. So the circumference is actually going to be 2 pi times 12. So that's 24 pi. That's going to go underneath my arc length. And that is equal to the degrees, so 30 degrees over 360. Now, how do we solve any proportion? We cross multiply to solve. So I'm going to cross multiply. So 24 pi times 30 is 720 pi. I'm going to keep it in terms of pi for now. You can multiply it out if you want to. Doesn't really matter. And then I'm going to cross multiply 360 times L. If I want to get just L by itself, I have to divide both sides by 360. So in terms of pi, the length of the arc would be 2 pi centimeters. Make sure we put our units. And if I was going to round that to say the nearest tenth, it would come out to 6.3 centimeters. So you can write in terms of pi if you want to be exact, or you can round. So that is how you find arc length. So I would like you now to try and find the measure of the length of an arc with the same circle, 12 centimeter radius, and now it's 105 degrees. So again, arc length over circumference, it's still the same circumference, equals degree measure over 360. If we cross multiply, we get 2520 pi equals 360 L. Divide, and in terms of pi, you should have gotten 7 pi centimeters. If you were to round, it's about 22 centimeters. So there is your arc length for B. Okay, number 2. A circle has an area of 1,296 pi. See if you can find the length of an arc with a central angle of 12. So I just put the circle there in case the visual helped you. We're trying to find arc length. We know that the central angle is 12 degrees. So if we know the area of the circle is 1,296 pi, we should be able to set that equal to the area formula, which is pi r squared, and solve for our radius, because we don't want to put area in our formula. We want circumference. So if we solve this, the pi's actually cancel out, and you get 36 for your radius. So that's the first step. Step 2 is now to find the circumference. So circumference equals 2 pi times the radius. So that gives us 72 pi. Now I can plug into my proportion. Arc length over the circumference equals the central angle over 360. Cross multiply, you get 864 pi equals 360 L. And divide. I'm going to leave this as in terms of pi and round it. So in terms of pi, you get 12 pi over 5, or 12/5 pi. Okay, we don't have any units here, so I'm just going to put equals L. And if you were to put that to the nearest tenth, it is 7.5. So that's a very similar question to number 1, except you had to do a little extra work to find the radius. For the next problem, and you're going to see this in your homework, we're going to talk about what it means to go 1 full revolution. So you think about when you ride a bike, for instance. When you ride a bike, your tire makes 1 full revolution when it goes all the way around the circle. So by that I mean the full circumference of the wheel. So in this specific example, the diameter of a bike wheel is 70 centimeters. Okay, make sure you focus on that, it's diameter. See if you can figure out to the nearest meter. Now watch out, this is in centimeters. They want to know to the nearest meter, so you're going to do some conversion here. How far will the bicycle travel if the wheel rotates 1,000 times? So the first thing I'm going to do is, if I know that 1 full revolution is 1 full circle or 1 circumference, I'm going to figure out what is the circumference of this bicycle wheel. So circumference is pi times diameter. So that means that in this case, it would be 70 pi. And that's in centimeters. So to go around the tire once, it's 70 pi centimeters. So if I'm going to go around 1,000 times, that should mean I should just multiply my circumference by how many revolutions I'm doing. And that gives me 70,000 pi centimeters. But remember, I don't want it in centimeters. I want it in meters. So in order to change centimeters to meters, you actually have to divide by 100. 100 centimeters is equal to a meter. So if you divide by 100, that is 700 pi meters. And they want it to the nearest meter, so 700 pi should give you 2,200 meters. So there's your final answer. See if you could try part B. How many revolutions will the wheel make if the bicycle travels 15 meters to the nearest tenth of a revolution? So the first thing I'm going to do is I'm going to change my meters to centimeters. So 15 meters is equal to 1,500 centimeters. Here I had to divide because I was getting bigger. Here I have to multiply because I'm going to smaller units. I'm trying to figure out how many revolutions there are. So I have to take my full length traveled and divide that by the circumference. So divide by 70 pi. Plug that into your calculator. You can go roughly 6.8 revolutions in that 15 meters. So you might have, well, not might, you will have some revolution problems in your homework this week. So definitely give those a try. Last but not least, this problem, there's one just like this in your homework. A wire is used to hang a decorative plate on the wall. The wire goes around the bottom of the plate and then hangs over a nail in the wall. The plate has a radius of 10 inches. See if you can find the length of the wire. So the first thing I automatically did was I drew in the radii, but I drew them in a very specific place. I know that when I draw a radius to a tangent at its point of tangency, because these are two tangents, that they are perpendicular to each other. So there are right angles formed right there. I also know that this is really a hat theorem. So whatever the length these are, they are actually going to be the same length. I know that the sum of a tangent-tangent angle and its minor arc should add up to 180 degrees. So if this is 60, then this arc is 120 degrees, which means that this central angle is 120 degrees, because remember, the central angle is always equal to the measure of its intercepted arc. So I just wanted to write this out just in case you need it. So remember, the two radii drawn to the points where the wire departs from the plate, so the point of tangency, will be perpendicular. So something else that's happening here is you actually formed a specific type of quadrilateral. You formed a kite. And in a kite, you actually have one pair of opposite angles congruent, and that's the angles formed by the long side and the short side. So that's also how we can confirm that these are 90. Because they must be congruent to each other, and 120 and 60 is already 180, so there's only 180 left over. So there's a couple different ways about going how to figure out all the angle measures here. So now that we have our diagram kind of filled in, I'm actually going to redraw it in a different way. So if I redraw just the kite aspect of the picture, and I draw in the long diagonal, if you remember your kite properties, the long diagonal bisects the angles. So if these are 10, okay, we know those are congruent and those are congruent, and this is bisecting the angles, then that means that each of these are 60 and each of these are 30. So what kind of triangle did I just form? Two 30, 60, 90 triangles. So if this is 10, then we know that each of these are 10 root 3. And those represent the pieces of wire that are coming off the nail. So we know that the length of the wire not in contact with the plate is going to equal 20 radical 3. 10 rad 3 plus 10 rad 3 is 20 radical 3. Now we actually have to figure out this whole piece right here. How much wire is going around the circular part of the plate? Well, that's going to involve our proportions. So arc length over the circumference. The circumference is going to be 20 pi because we know the radius is 10 inches. And that is equal to the degree measure. So the degree measure is going to be 240 degrees, because if the minor arc is 120, that leaves 240 degrees left over for the major arc over 360. And if you were to cross multiply and solve, you would actually get 40 pi over 3 as your arc length. So the last piece, the total length of the wire, is going to be that 20 radical 3 plus 40 pi over 3. So there's another problem just like this on your homework. Definitely give it a try, and I will see you in the next video.